We have a new 3D printer to test, so why don't we put it through its paces and try to do something challenging with it. Welcome back to Cloud 42. I'm James. This is the new Bambu Lab A1 Mini. This is their entry into the low end of the 3D printing market. The printer itself sells for $299, or you can get it in the bundle you see here with the 4-spool AMS Lite for $459. It's got all of the automatic everything that you would expect from Bambu Lab, and while it's clearly targeted at the home market and the first-time 3D printer buyer, I have something else in mind for it. Now, full disclosure, Bambu Lab sent me this printer free of charge in exchange for making a video about it. They didn't pay me. They have no control over the content of the video, but the link down in the video description is an affiliate link. So if you use it to make a purchase, I earn a commission. Now, I already have two X1 carbons and a P1S, and they live in another room where they can make all the noise they want and not bother anyone. But this thing is small and it's quiet, and I think it might be the perfect machine to have sitting on a corner of my desk to crank out prototype parts while I work on other things. The question is it up to the challenge of doing real engineering work? About 3 weeks ago, Christopher Helmke published a video showing how he 3D prints control panels for electronics with translucent windows in them for LED indicators. I'll put a link to his video down in the description. Definitely check that out along with all of the other stuff on his channel. That young man's got talent. Ever since I saw his video, I've been thinking about whether it would be possible to 3D print a panel with a 7-segment numeric display in it, like the one in my electronic lead screw control panel. Now, making something like this actually work would require extremely good control of multiple materials, fine details, and an absolutely perfect first layer. And that seems like a challenging test for a new 3D printer. And since I have a new 3D printer here that I need to test. Now, before we get too crazy and go spend a lot of time designing something complicated, what we need first is a proof of concept. This is a soldering practice board that I bought several years ago so that I could learn how to solder with lead-free solder. And yes, indeed, this is lead-free solder. And yes, I did solder this by hand. This board just has some blinking lights and some circuits that, blink and chase around with the blue LEDs. I believe these are 0805 LEDs on here, and this should make a good test bed just to test and see if we can make a 3D printed part that fits over this with windows that properly passes the light. Ultimately, I will design my own board for a 7-segment display, but let's see if this works first. I bought this board from Amazon, looks like back in 2019, and the listing has what looks like an assembly diagram for the PCB. Looks like this was output from the CAD software, so I just brought that into Fusion 360, scaled it to the correct size, threw a sketch on it, and defined some profiles around the LEDs that I want to bring out to the front panel. And then I just used this sketch to model up a proof of concept panel with clear windows in it for each of the indicators. Now we'll print this in black PETG for the body and clear PETG for the windows. The windows here I think are 0.6 millimeters thick. That should be 3 layers 3D printed, and you can see they have kind of a dovetail shape so that they're physically locked into that front panel. I don't know if adhesion between the plastics is going to be an issue. After talking to Christopher a little bit, he said that he had done something like this and dovetailed them in, and I decided to go ahead and give that a try. It's pretty easy to do in the CAD software, and it could potentially solve a lot of problems, especially if I need to make them really thin. Let me just dump this out to the A1 Mini, get a test part, and let's see if it works. And here's the first test print right off of the printer, and it honestly went pretty well. PETG is really sticky, and getting a clean first layer, especially something as detailed as this with all the little islands in the print, is not an easy thing to do, and this little printer handled it really well. You can see that that first layer isn't filled very well. There are some gaps between the extrusions. I played around with the settings and printed it again, and then I played around some more and printed it again and again and again, just trying to figure out what was going on with that first layer. And in the end, it turned out just to be the flow ratio. The default for this particular filament was set to 0.94. I found that if I turned it up to 1, I got a much cleaner first layer. Even this one isn't perfect, but some of the ones that you see later are much, much better. I did switch and use a Hilbert curve for the top surface here, and I think that really cleans it up and makes it look nice. It kind of imitates the texture you see down on the bed, as opposed to the lines that you would normally see on the top layer of a print. But the real question is, how does it work? And optically, this is really good. It's transmitting way more light than I really expected. I expected it to be dimmer than this. I really like this. I think there is potential here. I did another one with smaller indicator windows just to see how that would go. See if we get as much light through that. And yeah, it looks pretty good. I think we should consider the concept proven, and it's probably worth the effort to go and design a proper 7-segment display panel and give it a try. This is the design that I came up with. Now for reference, these are 12mm high digits with 1mm wide segments. And then on the back, the shields taper down to a larger opening that provides enough room for an 0805 LED, but I'm probably going to use like an 0603 just to make sure that the actual alignment with the PCB isn't that critical. Now, designing something like this is relatively complex. I'm not going to walk through the whole design here, but I will do a separate tutorial video showing how I designed this and walking through the steps to model it just as a learning activity. I know seeing something like this that somebody else made does not help at all if you're trying to learn how to use the tool. I've got the windows dovetailed in to cutouts in the panel exactly as I did on the proof of concept prototype. And I've got all of these bodies arranged into components. So there's a component for the panel and a component for all 72 individual segments of the lenses. And I did this to make it easier to output for 3D printing. You can see there are 72 bodies in the lens component. So all we have to do to output this to put into the slicer is go to File, 3D Print, and then I can select the panel component, output that as an STL file, and then we can come back and do it again, say File, 3D Print, and this time select the lenses component, and it will select all 72 of those bodies, and it will output them into one STL file in the same coordinate system as the coordinate system for the panel file. And that's what we need to bring those two files into the slicer to print a multi-material model. I'm using Bambu Studio here as the slicer, so I'll click the plus button and I will find those two STL files, the one for the body and the one for the lenses. Select them both with control click, click open, and it'll ask me, do I want to load them as a single object? And the answer is yes. So it's loaded both STL files and it has aligned them together. So now I'll just click the button up here and select the side that I want down on the bed. That will orient it, and now we can start selecting materials. I will select the Bambu PETG Basic in black. I am going to change the color that's shown here in the slicer just so that you can see the detail better of what's going on. And then we need to add a second material for the lenses. So I'll click plus and I'll select the Bambu PETG Basic in clear. So we have both of the filaments selected. I am going to change the flow ratio here. So we'll click edit, and here where it says flow ratio 0.94, I've found that I need this to be 1.0 to get good results on that first layer on this particular printer. And it changes it for both of them because it's using the Bambu PETG Basic preset. And we can come up here and click on objects, and we can see our two objects here. And I'm going to reorder these so that body is first and then the lenses. And then over here on the right, we can choose what material is used. So we'll just click on the lenses and we'll click the clear material. And so now the lens will be clear and the body of the panel will be black. And you can see it's added a purge block in the back there that it's going to use during the filament switches to purge out the old filament. Now I'll move that and make sure it's far enough away from the print itself that it won't cause any problems. And then let's go adjust some settings. So I've switched back to global, so this will affect all objects. And for the wall generator, I'm going to choose Arachne. And that's important when you have really thin walls and tight fitting parts and you want to close up those gaps. Under strength, I'm going to change the top surface pattern to Hilbert curve. That is purely aesthetic. And then over on others, I am going to add a couple of skirt loops around the outside of the part. Again, this first layer is critical and it has to be clean. And having those skirt loops printed first will help to make sure the nozzle is purged and clean and ready to go for all the detail on that first layer. And if we look at the preview here after slicing, we can see the first layer, the second layer, the third layer, And you can see the fill on those segments in the third layer doesn't look quite right. What that is that's the Hilbert curve, because that's the top layer for the lenses. And I would like to change that. There's the Hilbert curve on the top of the panel. That looks good. So we'll go back over to prepare and I'll click on objects again. I'll select the lenses and I'll come down here and change the top surface pattern from Hilbert curve to concentric. That's what I want on the top of the lenses. And I'll change the bottom to concentric as well. And then we can slice this again and see what it looks like. So slicing it again, there's the bottom layer, there's the second layer, there's the third layer. That looks nice and clean. I like that. And then we've got some infill, got some solid top layers with the Hilbert curve, and then it tapers up to the top of those shields. And that looks good. Let's send this to the printer and see what we get. The larger Bambu Lab printers famously have a poop chute in the back where they purge material out of the nozzle. The A1 Mini has a purge bucket here on the left-hand side where it purges out and then poops right on the desk. You can put a box there to catch it if you want. And then on the back of the bed, there's a little spring steel perforated sheet and a nylon brush that it uses to clean up the nozzle and then cool it down and keep it clean before it starts probing the bed. And honestly, I think this system works a lot better than on the X1 Carbon or on the P1 series. Especially with PETG, it's often possible to yank the purge material back out and drop it on the bed, and that just does not happen here. Then after purging and probing, there's a little pressure advanced calibration where it uses a pressure transducer actually in the nozzle to measure the pressure and adjust that. And then it starts printing. And you can see that first layer is really clean. PETG is sticky and it is a mess when things don't go well. And this printer controls it really well. Then the purge and switch to clear material works well. Prints the purge block, and then starts printing the lenses. And I have to say I've been really impressed with how it controls this first layer. Something this complicated on the first layer is usually not a good idea, but this printer handles it really well. And here are the results. Look at that first layer. That texture is just absolutely consistent, edge to edge, even where the windows are. I am really impressed with that. It's clean on the backside. I love the Hilbert curve. It's really nice. And those thin walls printed great. Those start as 2 extrusions wide and narrow down to just 1. And I'm happy with that. Now let's see how it performs optically. Of course, I didn't design a PCB for this yet. I'm just using the flashing LEDs on my test board. That looks pretty good through the indicator. What about the narrow windows on the digits? And those light up pretty well. Now, one of the things that I'm noticing is there are some really serious hot spots there, right behind where the LED is. It's a really bright spot. The camera may not do that justice. The whole thing's illuminating, but I would really like to have a little bit more diffusion. It's possible that this clear material isn't the best choice. I printed another one using white PETG instead. This is the clear, this is the white, just so that we could get a little bit more diffusion and see how that looks. I think I've got this, I think this is 2 layers of white, 2.2 millimeter layers. And yeah, it does light up, not as much light is getting through. And then of course the white color itself is so bright just from the room lighting that there isn't really a lot of contrast there. The diffusion is excellent, right? That whole digit is lighting up. It's nice and even. There are no hot spots, but even when the digit is off, it's still pretty bright just from the room light. And admittedly, my shop lights are bright, but I'm not sure the white is going to work. The AMS on this printer, however, can handle 4 materials, so let's go ahead and just add another material. So what I've got modeled here is a clear lens backed by a white diffuser. So the diffuser here is 1 layer thick. I think the lens here is 2 layers thick. Print the lenses in the clear PETG and then put the 1 layer of white PETG behind it as a diffuser. The idea here is that the front panel is not going to be as bright. We're going to get the strength of a thick lens, but we're only going to have 1 layer of PETG in there as a diffuser. And we just do exactly the same thing. I've got the body as 1 component, the lenses as another component, the diffusers as a 3rd component, And we'll just output all 3 of those as an STL file to the slicer, select a third material, and print it. And here's the result. As usual, that first layer is just absolutely perfect. Here it is next to the white one. You can see it's a little bit dimmer than that. It's quite a bit brighter still than the clear. And it's clear material on the front. You can kind of see that single layer of white diffusion from the back, but the real question is, how does it perform? And the answer is it performs pretty well. I kind of like that. There's plenty of diffusion there. There's no hot spot. Those segments are lighting up fully, and they do seem bright enough to me. I'd want to make sure I use a nice hot LED or a nice bright LED for the display, but I think that's practical. Now, if we put this over a larger light source and look at this with the lights turned down, we can see one little problem here. There are some light leaks around the sides of these. There's a little leak right there where the light's getting around the side of the diffuser. There's another one over here. So it's not perfect. And those are just situations where the light's getting around the diffuser. It's an imperfection in the diffuser layer that's printed in there. But again, we have full control of this part in a 3D printer, so we can come up with a solution for that. I came back into Fusion 360 and I replaced the individual diffusers with a sheet of the diffuser material that goes across the entire panel. This is 0.2 of a millimeter thick, and if we highlight the component, you can see that it covers the entire display area. Now, this is embedded down within the panel plastic, so there's not really an adhesion issue. It's still a continuous material 3D printed, just that one of the layers in there is a different color. And this will completely prevent light from leaking around the edges of the diffuser because the edges of the diffuser are not exposed. And we've got a nice slot in there. And this is fun. You can actually fly down in there in the 3D model. I have a space mouse that I use for navigation. I highly recommend it. And you can do fun stuff like this in your YouTube videos. Okay, that's enough screwing around. Let me send this to the printer and let's see how it works. Now, for some reason that I wasn't fully able to understand, I couldn't get the slicer to generate just one continuous layer all the way across, but I did get it to generate a bunch of different fill regions that at least overlap the sides of the openings so that there aren't going to be any light leaks, but I'm not really sure what happened there. I don't know if that's a bug in the slicer or if that was just something I was doing wrong, but either way, we got a good result. And here's the finished part. And unsurprisingly, it looks exactly like the previous one. You cannot even tell that there is an entire layer of white plastic embedded in there. This is one of the things I love about 3D printing, is that you can have such good control over the interior structure of a part like that. I don't know what other manufacturing process can do that. The performance looks good here. I was a little bit worried about light bleed from one segment to adjacent segments, but I don't see any of that. And over a diffuse light source, I don't see any light leaks at all, which is not surprising because there are no edges for the light to leak around. I did try reprinting this with a 0.1 millimeter diffuser layer, and it looks okay. I think the 0.1 millimeters is a little bit too thin. You can see that there's a little bit more brightness. You get a little bit more light transmission. It's still relatively diffuse, but if you look at this over a diffuse light source, you can see some imperfections. You can see some places where black plastic got drug in, and you can see some little kind of hot spots. And 0.1 millimeters is just really, really thin, especially for PETG where it's so sticky. The nozzle tends to pick up more residue. If we put these side by side, you can see the one on the bottom with the 0.1 millimeter layer is brighter, and the one on the top that has the 0.2 millimeter layer is cleaner. I don't think the added brightness is worth it to me for the loss in accuracy in the print, so I think the 0.2 millimeter version is the winner. I have to admit, when I first saw this little printer, I was pretty sure it wasn't for me, but I also have to admit that I've kind of fallen in love with it. It's fast enough to crank out parts quickly. It's quiet enough that I can work right next to it and even take conference calls in the same room while it's printing. And it's clearly capable of doing the kinds of work that I do. Now, it isn't enclosed, so I wouldn't try printing ABS or nylon on it, and it doesn't have all of the hardened parts you would want for carbon fiber. But for PLA and PETG, it's a solid little machine. The only other note that I would add is that it does make more noise when printing PLA because of the cooling fan, but it's still quieter than its big brothers. If you enjoyed this video or found it useful, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I would like to know what you think. As always, all of the files for this project are available on Patreon, and if you're already a patron, thank you. You make it possible for me to do this. Thank you for watching.